Welcome to another episode of Math Snacks with Miss Glovely and Miss Wonderful. Trick or treat, smell my feet, give me something good to eat.
Miss Wonderful, are you still working on your jack-o'-lantern?
I am. I'm having so much better luck now that I understand about those side lengths.
Oh, that's good. I'm glad you learned from our last episode.
Not near as frustrated.
So what are we going to talk about today?
Well, I have noticed that some of my triangles that I've made all have, like this one, all have the same length. And I'm just having to make sure that the two lengths are, greater than that third one. But I'm confused because I'm not sure if they have different names or what to call these triangles. If I told my friend how to make them, I'm not sure I could describe them.
Okay, well then maybe we should talk about the three different types of triangles today.
That'd be good.
Okay, well,
I need to stop what I'm doing.
Maybe you should put the jack-o'-lantern away for a while. Okay, we have equilateral triangles, and we're gonna have to move them, and an isosceles triangle, and our third type is a scalene triangle.
I think I was making. Let me look again. If I bring it down another, I think that's an equilateral triangle.
Well, what do you notice about this equilateral triangle?
The point faces up.
Does it have to? What if we turn it like this?
Well, I don't know. That doesn't look like my jack-o'-lantern anymore.
Well, but what if we do this?
Oh, well, I guess it's the same.
It's the same.
It's the same.
So what do you notice is the same about the sides of the equilateral triangle?
I measured these all to be 1 inch.
So they were all the same length. All three sides are the same length. When I taught students this, a little trick, you want to know a little trick that I used?
Yeah.
Okay. What's the first part of this word?
Equal.
Equal. So I taught them that if they saw equal, all three sides were equal.
And I know that equal also means same as.
That's right.
So equal means all three sides are the same as. I'm going to just do this. Equal.
Right.
Kind of spelled wrong, but that's okay.
Close.
Okay.
It gives you the same sound. Okay.
Should we move on to the next one?
Let's look at isosceles. What do you notice about the isosceles triangle? And you might need to use your ruler to check this out.
Okay.
Because it's taped to the paper.
Well, this side length is 5. And this side length is 5. And this side length is 2.
So, in this triangle...
I'm going to write that down so I don't forget. I have a bad memory. 5, 5, and 2.
Okay.
So all isosceles triangles have 5, 5, 2.
Well, not exactly, but what else do you notice?
That 2 plus 5 is greater than 7 is greater than 5.
Well, that's true.
Because we learned that last time, too.
That's true as well. Do you see that they have two side lengths that are the same?
I do.
That's the rule for isosceles, is that at least 2 of the sides have to have the same length. Now, I have
a question.
Okay.
At least 2 sides have to be the same length.
Right.
Back down to this one.
Okay.
It has 3 side lengths.
Right.
So at least, does that mean in equilaterals also an isosceles?
It can be.
Okay. But it's a more specific name because it's all 3.
Because all 3 sides are the same length.
Okay.
Okay. In an isosceles triangle, at least 2 of the side lengths have to be the same. Now, I'm going to tell you something here, and I'm getting a little bit ahead. I had students that could always remember equilateral because of that word equal. But I then had kids that would confuse isosceles and scalene, and they needed a way to remember. So remember we had a trick for equilateral?
The word equal was kind of in it.
Right, kind of. It's misspelled, but it's close. Well, what does the word isosceles start with? Eyes. And how many eyes do you have?
I have 2 eyes.
2 eyes. So 2 of the side lengths are the same.
So eyes, but it's kind of like eyes.
Right, and we have 2. There you go.
Okay.
So a little mental model for isosceles was that we have 2 eyes.
Gotcha. So we have equilateral.
Upside down.
But is it still? It's still equilateral, right?
It still is an equilateral triangle.
No matter how I flip these things, that's still an isosceles.
That's correct.
no matter how I turn them.
Right.
Okay.
I love this upside down reading. All right, that leaves us with scalene.
Mm-hmm.
Well, last time you measured, so maybe we should measure again.
We've got 5 1/2.
Okay.
We've got 4. I'm measuring in inches. I hope that's okay.
That's fine by me.
And we have 3. None of them are the same.
None of them are the same. So scalene is the one that none of the side lengths are the same. What do you think?
I think it'll be really easy for me to remember eyes, because I won't forget that one.
Okay.
And equal, because it means same as. I think it'll be easy for me to remember. Scalene
is the other one. Well, that's the other one.
Just what's left over has to be that one.
Has to be the one that none of the side lengths are the same. But it still has to follow your property that you learned in the last episode, where your 3 and your 4
have to be
greater than your 5 1/2.
Gotcha.
To make a triangle.
Uh-huh. And no matter if I turn it this way, 5 1/2 and 3 have to be greater than 4. Doesn't matter which one's the base.
That's right.
Which 2 I'm adding. Cool. Okay. I'm thinking like maybe the word lean, like because none of the side lengths are the same, it'll start leaning and falling.
Well,
that might help me.
Maybe that will help you remember.
That's how I'll remember it. Lean meaning it's going to fall back and forth because it doesn't have anything the same.
Okay.
Okay.
Well, I hope that helps you remember the different types of triangles, and maybe that'll even help you on your jack-o'-lantern somehow.
Awesome. Well, I could definitely describe my jack-o'-lantern to people now and say it has an equilateral nose and an equilateral eyes.
There you go.
So
I'm glad we could figure that out.
Thank you for joining us in another episode of Math Snacks.